or let us say night for you. You were you were waiting for that flat slab concept. Yes.
Yes,
Hello.
sir.
Yeah. Yes. Hello, Suleka madam. Can you hear me? Hello.
Hello, sir. Good evening. Good evening,
Good
sir.
evening. Good evening. And today you will be very pleased because today is the time we are working on flat slab. Okay.
Okay, sir. Okay, sir. Thank you.
Yeah. Actually, this is not actually included in our program, but as per your requirement, and I also feel that let us other the people who are in India, they must know something about flat slab. Okay. Yes, Avinash.
Okay, sir.
Yeah,
Yes, sir.
Avinash. So today we'll
Yes.
be going for some information about flat slab, how we can take the help of SEP to create the flat slab and design it. So let us uh, dive into it. So I will open the AutoCAD, and it is very preliminary because I am not going for any complicated because this is your first session. So I have thought that let us say this type of structure that we are going to construct, and these you can see these red columns. So this red area, this is your column position. So you can see that a grid, here is the spacing of grid: 7.93, 6.1, 6.1, 8.23, 6.1, and you can see 5.48 on y direction. Yes.
Yes, sir.
Hello.
Yes, sir.
Yes, sir.
So yeah, so these are the columns in the and this is the L-shaped slab, and this portion is for staircase, and that's why here we are considering it as a void, and it is having area like this. So this is your you can say wall. Okay. Let us work on the geometry first. Now I have considered a beam on this line and on this line. So top line and this line, this is the external line, and we are having a beam, and that beam will be L-shaped beam, and these are the columns. And as these columns are supported by beam, you don't have this type of capital, okay, or drop panel. Clear? Hello.
Yes,
Yes,
sir.
sir.
Yeah. Now you can see we are considering the size of beam as 300 by 600, and this is the web portion. This is a flange portion, which is 1500 or 1.5 meter, and it is having a slab depth of 250. Okay. So the beam property, you can say that 300 by 600, and L shape is of 1.5 meter and 250 deep. Then the slab, this is entirely a slab portion, except this void. The slab is of a 10-inch, or let's say 250 mm. Okay, and all these yellow, these indicate the capital or a drop panel, right? So these are the drop panels, and size of drop panels that I have considered as 1.8 meter by 1.8 meter, and the depth of drop panel is 400. Now this 400 includes this 250. Okay,
Okay, sir.
clear? Now the
Clear,
size of
sir.
the size of the column. All the columns are having a size of 450 by 450. So you can see that all these red parts, this consists a column. Okay. So these are the columns, and these are the slabs. So internally, you don't have a beam connected to from this column to this column. Instead, this is a wider depth, and that is called a drop panel. And entire slab is directly resting on beams. I mean columns, not beams. Okay, except this external portion. So external portion is having a end edge bars. This L type. This is having beams. Then the wall thickness, the thickness of the wall that I'm considering is 300. So this green portion is showing you the position and location and orientation, etc., of the walls. Clear?
Yes, sir.
Yes, sir.
Now you can see that this drop panel, this is projecting all over the side, because on all four sides of this center you are having a slab. But here you can see that you cannot have outside this, you cannot have a drop panel, so only inside panel. Okay, and at corner what will happen? At corner you will have a drop panel size only of this type. Okay, and uh, this line this line indicates the entire slab. Clear?
Clear, sir.
So this is our problem, and now we are going to create this. Now how this slab is supported, because normally we feel that slab has to be supported on beams, then beams will be supported on columns, and columns will be going down, and they will rest on either isolated footing or mat or etc., whatever, right? So that is our conventional RCC. But most of the times, when you are going in commercial areas, what happens that you can say that entire this part you can consider it as a hall, and then the panels are also big. You can see that uh, this 7.31, and this is 6.1. Now you can just imagine that if you want to have a slab of 7.31 by 6.1, then the depth of the slab will be very high from the criteria of the deflection. So then you will say that you must have a beam over here and a beam surrounding on that, and that is detrimental to the architectural feature. So architect does not want, or the owner of this building does not want any beam. So then how this slab will transfer entire load or directly on column, on this column, etc. So that is the flat slab construction. I think all of you might know something about flat slab. Hello? Yes or no?
Yes, sir.
Yeah. See, in flat slab, actually, you can say that this is your column strip. Let's say I will draw it. It will be something like this. This is your column strip. Okay. Then this will be something like this as your column strip. Okay. Uh, Let me do it correctly. So this will be considered as column strip, and the remaining portion will be considered as middle strip. Now this middle strip is resting on these column strips. So it will have a spanning in this direction, and these column strips will have they will rest on these columns with the help of uh, this capital. Okay, so that is the idea how it is constructed. Now we'll see why this portion. Now, if you come to this area, you will see that this slab, this slab, this slab, and this slab, it will try to transfer the load on here. So in this area, there will be very high shear stresses. Now to take care of that shear stresses, you can say that you are having a slab thickness as 250 only. So that is not sufficient. So near the columns, the thickness of slab is increased, and finally you will see a picture something like this. So if I see, it will be something like this. It will be something like this. And there are ways, and finally this will have a column something like this. Got it? Clear?
Yes, sir.
Yes, sir.
Yeah. So this type of construction you will see everywhere at the corners. So I will erase it. And now we'll, with this information, we'll try to create this uh, in uh, in our SAP software, and we'll try to analyze and we'll try to see how the detailing of uh, middle strip, then edge strip or column strip, either in this direction or in this direction, how the reinforcement is placed, uh, how the reinforcement is placed in this column capital or drop panel, etc. Okay, so for that, let us this much is clear, yes, or anybody having any query about this type? Many of you have not gone through the design process of that, and this tutorial I'm just explaining the concept, how that flat slab or PT slab, you can say this as a PT slab, or simply reinforced flat slab with capital, you can say that, and you can create the reinforcement detailing with the help of SAP. You can definitely you can do it manually also, and there is a process how to design flat slab with column strip and middle strip, etc. So you can go through that data, but here we will be going for creating this in SAP software, and asking the software to analyze it, and based on that we'll go for design. Clear?
Yes, sir.
Okay, now the actual process will start. Mm, let me go to this. Me go to this also. Okay, now I will open the set. So double click on that icon, and you will see that it is creating. So this is your first. Then let us so click on this. Okay, and go to file and create new model. Okay, as usual, we'll have to go 456, then check it, merit, metric units are there, and see the design preferences, IS 456, 1.5 for concrete, 1.15 for steel, and 1.5 for concrete, and then go to minimum cover for slab. So for minimum cover, now this is not your foundation slab, this is your actual slab. So we'll go for 20, 20, and we'll be going for preferred bar size that we are going to use in this will be 12 mm. Later on, we might go to 16. That's okay. And click OK. Okay. After that, you will have to go for cover to main beam. Now, because on the edge, L-type edge, we are going to construct beams. So click on that, and in that case, you can say clear cover at top. You may go for 25, and clear cover at bottom. You may go for 40, because you might be using higher diameter steel, longitudinal steel. Then preferred bar size for beams, you may go for say 20 dia, and preferred bar size for shear, that is for stirrups, you may go for 10. Okay, and then we don't need this PT stress check, so we'll click OK. So now we are going to create with the help of grid. So click on grid only. Immediately you will see this Cartesian. Click on, if this is not clicked, then click on this Cartesian instead of the cylindrical. So we are going to use Cartesian coordinate system. So click on or highlight that Cartesian. Then in X direction, now, okay, I have, okay, 1 minute. I have to open that drawing. Okay, then let me do it. So there are 6 numbers in X direction and 7 numbers in Y direction. Then in X direction, I was having, or you can say, it was something around 6.1. So 6.1, and this was something around 5.48. Later on, we will edit it. So don't worry about whatever spacing that you are providing over here. I will click OK, and this is, and then I will go back to the drawing. Unfortunately, I closed it. Let me go to that. Okay, so this was the drawing. Now you can let me close this. You can click on that again, and you can see in X direction you are having 6.1, 6.1, and 6.1. Only this is 8.23, and so first and fourth, so 7.93 and 8.23. And if you see here, everything is 4.4, 5.48, 5.48, and this is 7.31. So we'll have to revise our or modify our grids data. So in first 7.93 and 8.23. So go back to that where it is. क्या मैंने क्लोज किया क्या?
I think sir. नहीं सर.
यहाँ पे क्लोज करता हूँ, ज्यादा हो रहा है. Okay, I will reopen. एक्चुअली यहाँ पे क्लिक करने के बजाय शायद मैं यहाँ पे क्लिक कर रहा हूँ समवेयर. इट इज गेटिंग क्लोज. ओके, विल हैव टू डू इट अगेन. ओके, फाइल, न्यू मॉडल.
सर सेफ का चालू है पहले वाला भी फोल्डर.
कहाँ पे है?
नीचे देखो सर, वो सेफ का जो सिंबल है ना, उस पे 2 टैब चल रहे हैं अभी.
1 मिनट. तो ये क्लोज करूँ? या याद
Yes,
है.
sir. हाँ.
या चालू है. Yeah, it is going on. Okay, so we have to make it 7.93 and this one as 8.23. Okay.
Yes,
So,
sir.
and these two as okay, we'll do that. So go to edit and go to grid data and go to modify grid. So global, modify show system, and first you come to this this thing. So instead of this 6.1, it is how much? It is 7.93 and 8.23. Okay, so this is 7.93, 7.93, and this is as 8.23. Okay, so this is 5.48, 5.48, and this is something 7.31. So 2 times 7.31 and then 5.48. Okay, so this is 7.31. Clear?
सर वो शायद सी की वजह डी में आना चाहिए सर 8 पॉइंट
Which one?
सर इन द एक्स ग्रिड डी में आना चाहिए सर शायद
See, this is first spacing. This is second. This is third, and this is fourth. Yeah. Yes. So this is 6.1.
यस सर
6.1, and this is 8.23. 8.23. And then this is 7.31 and 7.31. Okay, then 5.48, 5.48. So 2 to 738. Now you can check it over here. So I think it is okay.
तो सी
So this is our grid. Now you are having one grid and there is one horizon also. So you can hide this horizon so that you will understand this grid properly. So for that, either you can go to this set display option, or you can go to view and set display option. Either way, and see here this horizon. So uncheck this horizon so that everything will be very clean. Okay. Yes.
Yes, sir.
Okay. So I will save this. So for saving, he is asking me something. So I will say that flat slab. Flat. Let me have capital. So FLAT, flat slab construction. Flat slab design. So flat slab design, and with this I'm the tutorials I am saving. You can save wherever you want. Okay. Now the grid is created. Now, as usual, in ETAB, so we have to add new material. So the material that I'm going to use is M25. So I'm saying M25 for concrete. Here I will choose concrete, and here you can the property. So this will be 25,000. Now I'm not explaining this because a lot of times we have done it. Yes,
Yes, sir.
clear?
Clear.
So
क्लियर सर
M25 has been defined. Similarly, we have to define a rebar. So I will say that HYST 500, and here I will use a rebar. Then this will be 78.5, and this will be 200,000. 1, 2, 3. Okay, and this will be 500, and this will be 545. So I have defined the material, and now we are going to define all these properties. Okay, unless we define these properties will not be available to us. So let us start with beam, then slab, then drop, then column, then wall. Okay, one by one. So for beam, we are having 300 by 600, 1500, and 250. So let us go to that. Go to define, go to beam properties. Now in beam properties, right now there are no properties. So add new property, and this is your beam. So your beam is 300
into
by
600.
600. Okay, or you may say that you may have the same property, that 1500 and 250 also here with this 1500 by 250. Name, you can see it, give any name. The only thing is that why I'm giving this name, because immediately I come to know that this beam is having size of 300 by 600. then that flange BF or width of flange is 1500 and depth of flange is 250, right? Or you may say B1, B2 as per your choice. So the material that I'm going to use is M25. Then rebar material that I'm going to use HY 500, and rebar material for shear also I'm going to use 500. So HYSD 500. Now here, see the beam shape type. There are various shape types that are being, you can define T beam, you can define L beam, you can define any general beam, or you can say rectangular beam. Right now we are going to use L beam because it is applied on the periphery. So that L beam property that I'm using. So web width at top will be 300. Web width at bottom will be 300. So this is this top will be 300, bottom will be 300. Then depth of the beam will be 600. Then okay, so we are using 600. So this will be 600. Then flange width, instead of 300, now it will be 1500, right? And what will be the depth of slab? That is
250.
flange depth
250.
will be 250.
250.
Yes, so 250. So you can see this type of beam is defined over here. Now this is this section will be used for analysis property, and this section will be used for design property, and both sections in our case are same. Then you can check it over here. Then see here design property data. So this is analysis property. Now you can go for design property data either with this flange dimension from analysis property data. As per analysis property data, you can use this, or you may say automatic from slab property. So based on slab property, this can be used, or you can have user specified. But mostly we are going for this range dimension from analysis property data. So this will be highlighted. Then cover top. So top cover to the centroid. So how much it would be? Something around 50, not more than that. Yes. The top. See, maybe 25 plus 10 plus 10. So it may be 45 to 50. So you can say that it is something around 50, right? And right now we are not going for if you click this, then this will not be considered. So you will not this SAFe software will not consider design. So that's why keep it unchecked. Clear?
Clear.
So this is how you can define the beam property. So anything that you have not understood? Yes. Can I say okay over here? Because this is the only beam that we are going to define in this tutorial. So that's why, or you may see my recorded session later on also. If you have practically, when you will start creating this, you will have a lot of problems. So that time you may go back and see this and do your practice. Or if you are having any doubt right now, you can ask me. Yes, anybody?
No, sir.
Excuse me, sir.
Yeah.
Sir, 1500, how you obtained, sir, for this flange width?
Okay, actually, in that case, you will have to go through the codal provisions based on your total slab effective width of the flange. So for L beam and for T beam, that is B effective is equal to L0 plus BW plus DF by that I think L0 by 6 plus
Yes, sir.
yeah,
Plus
so that
BW plus 6
plus
DF
6 DF.
for
So
yes,
yeah,
so for
so based on that,
T beam and L.
yeah, and half for that L beam. So you can
Yes.
use that data, and based on that, I have assumed that this for initial conditions. Later on, you may reduce or like that. Clear?
Okay, sir. Okay.
Yeah. So you will get that calculation of flange width either in any book, or you may follow IS 456 or ACI. If you are using ACI, you may follow the ACI codal provisions, and based on that, you can calculate the effective width of the flange, and depth of the flange will be depth of the slab. Yeah. So then click OK over here. So your beam property is defined, and there is only one beam right now. So it is okay. Now we have to define a slab. Okay. Now let us go in the drawing. See here, slab for drop beam also it is considered as a slab, and for a normal slab also it is considered as a slab, and that's why for slab we are going to define a slab 250 and drop 400, right? Because depth of the drop that we are considering right now as 400, and if it is not sufficient after analysis, we might increase the depth of drop, but right now we are going for 250 and 400. So these two are the slab properties. Okay. Because even if you feel this like a column, it is not a column, it's a part and parcel of slab, or you may say that it is a slab having greater depth than the ordinary slab, right? Yes.
Yes, sir.
Yes, sir.
Yeah. Then okay, then we'll let me do that. So I'm going to define, now I'm going to define slab properties. Okay. Now add new property. Now the first I'm considering to create a slab property. So my slab is having a depth of 250. So I'm considering this slab 250. And then concrete that I'm going to use is M25, and the type analysis property data type is slab, and thickness of that is 250. Clear?
Clear.
Then thick plate, click OK. So the slab 250 has been defined. Similarly, we have to define another slab which is of 400. So click on that. Now here I will call the name as drop. Okay. So DROP, and depth I'm considering 400. That's why I'm defining it as a drop 400. What will be the material? M25. Okay. And what will be the analysis property data? Now it is not a slab. Let us see. Yes, actually there are various. So out of that, drop. Okay. So this is a name. This is the grade of concrete that you are going to use for the drop, and this is the analysis property which is a drop, and this is the thickness where you are defining the thickness of drop as 400 and thick. Okay. Got
Okay, sir.
the difference between slab and drop? Because slab is having a slab property for analysis, and drop is a slab having a drop property for analysis. Clear?
Yes, sir.
Yeah.
Yes, sir.
Okay. Now we have defined slab, we have defined beam, then we have to define column. Okay. Let me close this. Let me go back. See, here there are few columns which does not have a drop panel, and there are other columns which are having a drop panel, right?
Yes, sir.
So we have, though the columns are 450 by 450 everywhere, the edge columns are also having 450 by 450 as their cross-sectional dimension, and interior columns are also 450 by 450, but interior columns are having drop and edge columns on the right side, they does not have a drop. So that's why I'm going to create two column properties. One is a column with drop and another is column with no drop, right?
Okay, sir.
Yeah. So then I'm going to define column properties. Now here, add new property. Now this column, I might say a name as 450 by
450.
okay. So this is a column that 450 by 450. Then the grade will be M25. Now the column shape will be rectangular and parallel to two axes. Now you know the two axes, but right now here both the dimensions are same. So you're going to use it as 450 by 450. Clear?
Clear.
Now this will act as a rigid rigid zone area. So that's why click on this, include automatic rigid zone area over column. So whenever you will use this property, automatically this SAP software will create this as a automatic rigid zone. Okay.
Yes, sir.
Now you can see I'm not going to draw the drop panel over here. I'm going to use this. So automatic drop panel dimensions. So if I provide a dimension over here, and if I provide the property of that slab, he will directly draw it whenever you will use this property, right? Now include automatic drop panel over column. So now over column, now you can see that we are having a drop panel size of 1500 by 15. Let me
Sir,
check.
1800, sir.
1800 by 1800. Okay. So here you have to provide it a length of the drop 1800. Okay. Now never ever miss this, a slab property. Now here the slab property that you have defined for drop as drop 400, right? जल्दबाजी में लोग यहाँ भूल जाते हैं और बोलते हैं हमने तो ड्रॉप प्रोवाइड, तो वो ड्रॉप भी 250 का ही प्रोवाइड करता है, बिकॉज यू हैव चोजन दिस, और उसको ड्रॉप भी नहीं बोलता. देन फ्लैट ड्रॉपलेस फ्लैट स्लैब इज क्रिएटेड by the SAP. So check that you are using property as drop 400, right? Now there is no capital when sometimes you may have two drops, one wider and then one smaller below the wider. So that time you can use column capital, drop cap dimension, etc. So okay, let me explain this so that then we'll go see as if this is my slab, this is my drop. Okay, and sometimes what happens in this area, even you don't have this is not sufficient. So in that case, there is additional drop like this, and then you will have the column like this. Clear? So this is called a column capital. This is a drop, and the bottom is called a column capital, or sometimes this capital is something like this also.
Yes, sir.
पुराने मंदिर में जाके देखो, ऐसा कुछ कंस्ट्रक्शन दिखाई देता है, right?
Yes, sir.
But right now we are not using this type of structure. And that's why we don't need that this. Okay, so make it unchecked, click OK. So you have created one property which is column 450 by 450. Now another column property where you will be having the size as 450 by 450, but it will be having no drop panel. So I will go with that, add new property, and here I will consider this as a column dash no drop. So I will understand that this property, whenever there is no drop panel, then I will use this property, right? Then material will be 25 and uh, column will be uh, rectangular with size as 450 by 450 or whatever size that you have decided. Then include this because this also must have this. But now don't click on this. Otherwise, he will ask you the panel. Okay. And so this is unchecked, this is unchecked, and this is okay. So one is column drop, another is a column width drop. These are the two properties. Now, like this, you can create, if you are having different size of columns, you can create other sizes also. Clear? Hello? Yes, am I audible?
Yes, sir.
Yes, sir.
Yeah. Okay, then I will save this so that my work will not be okay. Now we are here. We have defined the beam. We have defined slab, drop, column. Now we have to define wall. Okay, so go to define and check that wall properties. Now here I will add new property and I will say a wall of 300 sides. Okay, then it will be concrete and this will be 300 as it is there. And outer plane I do not want, but I want include automatic rigid zone area over wall also, and click OK. So the properties have been defined. Now you can check your load patterns. So as there already their dead and live loads are there, so you can say okay. Then you can go and see the load cases. Now if you want to see the properties, you can go into the modify showcase, and here load case name is dead, then load case type is static, and you can see a scale factor. Okay, similarly you can check this also, load case. So automatically whenever you define that, load case is automatically included in that. Now you have to see the load combination. So again, the same process. Combination 1 will consist of dead load scale factor 1 and live load as scale factor 1 and service normal, and click OK. Then add copy of combination, then combination 2, I will change this as 1.5 and 1.5. Then uncheck this and check the strength. Okay. Okay. Clear?
Clear.
So what is left? So you can check materials, slab properties, beam properties, then column properties, wall properties. Now it is not a foundation, so you don't go to soil subgrade properties. Then spring properties are also not required. Coordinate system, groups, mass source. We are not going for earthquake analysis. Load pattern, load case, load combination. Okay. So everything is clear. Now you are free to draw. Yes, ड्रॉ करेंगे?
Yes, sir.
Okay, now go to draw. See, you can use this draw or you can use this draw, but I will use this because I am having L type of structure for slab. So I will go to this and check that you are having 2 panels over here and 3 panels over. So this blue line, okay, so this is your line, but now you can see that your grid line is this, and it is outside the grid line by 225, because 450 is the width of the column, so it is outside 225. But right now this point is not available. So what we can do, we can use this grid point to create, and then we can go for this. Okay, let us see the property first. So 2 and 2, so there are 4. Okay, okay. So go to draw areas. Now here, don't go for drop, because you are drawing slab, right? So the type of object is slab, then property is slab 250, and drawing type is straight line. Clear? Hello?
Yes, sir.
Then click on this point. Click on this point. Click on this point. Click on this point. Click on this point and click on this point, and then enter. Okay. Clear? The slab is drawn. Yes or no? Hello.
Yes, sir.
Okay. Now, one thing is that this slab is having expansion, or it is on left side upward, right side downside, left side and downside of 225 mm. So you have to expand this area, and for that, first go to the select object, then select any point inside the slab. So the slab is selected. Check it over here. 1 area and 6 edges are selected, and after that, go to edit and see edit areas. In edit areas, you can go to expand or shrink. Either you can shrink this area or you can expand area, and this is the dimension by which you will expand. And what should be the dimension? The dimension is in mm, so it is 225. And positive means it will expand, and negative means it will contract. Clear? Yes? Hello?
Yes, sir.
Then click
Yes,
OK,
sir.
and you can see the slab has been expanded on periphery, outer side. Got it? Hello?
Yes, yes, sir.
Now,
Yes, sir.
yeah. So now you can save if you want, and see, the next step is draw the columns. Okay, and see the columns. See what I will do. I will either draw the column like this, either draw the column like this, or I will have the columns drawn on this side, and then I will delete the columns over here. Okay. So all these columns are having drop capital, and remaining columns over here does not have a drop capital, right?
Yes, sir.
So you can select this point and drag it down to this, and you will find that everywhere column with drop will be added. Let's see. So draw. Now you are going to draw columns. So I will click on draw columns. Click on it. But before going, check it. What property that you should have over here? Yes. Hello.
Yes, sir.
Now you can see property above. See, property below is a property of the column. Property above, I don't want a column above this. If I click here and use it here, then he will have a column above the slab as well as column below the slab. But I don't want, so I will keep it none. So I don't want any property above this plan, right? Then hide below. Now let's say that this is a commercial area, so you're not going to construct it with 3 meters. So maybe something around 4.5. Let's say 4 meter. So that depends on the architectural data that you are having. But let's say that here we are having a 4 meter height from the base to the slab, and that is height below. Okay, so the height below will be 4 meters. What will be height above? As there is no property, there will be 0. Okay, then plan offset x 0, plan offset y 0, angle I don't want any inclination, so angle will be 0, and this is a cardinal point, and you can see a cardinal point over here. So 10. I will let you know something around this cardinal point a bit later, but check that it is a 10 over here because it is of the centroid. Okay, so we have finished the input data over here, draw columns, and I will start from this and I will drag like this. Yes.
Yes, sir.
Or you can delete this, or you can do one more thing, that redo it and go to draw columns, and check the properties are same, and you can draw it something like this, and then you can draw something like this. It is as per your choice, right?
Okay, sir. Yes, sir.
Yeah, and then go to this or use escape so that you will be out of the draw command. And now you can see here the drop panel, though it is having 1800 by 1800, it is not added on the right side, automatically done by the software. And that's why I always say that this safe is the best software. Okay, in that case, now what is left? You can see that these are the 4 columns that you don't need, so you can delete them, right? Yes.
Yes, sir.
Yeah, here there are no columns. Okay, now what about these columns? Now you know what to do. Just go to draw columns, and in draw columns, instead of this property, you will select property no drop. Rest of the things will be same. So height will be 4, below 4, then everything will be same. Only the property you will change, and you will draw it like this. Clear?
Yes, sir.
Okay, now you can see. So everything has been drawn. Now what about this wall? How you will add the wall? Very simple. Just go to your data and see the data over here. And what is that data? The length of the wall is not up to the your grade points. It is somewhere 7.1 on this side, 7.1 on this side. Thickness is 300. That you have defined in the property. Yes.
Yes, sir.
So what we will be doing? We'll be going to draw walls, and in draw walls we have to draw a wall from this point to a point where it is a 7.1. So for that, a simple construction I will do. I will go to draw, and before going to draw walls, I will go to draw points, and in points, y offset, how much it will be?
7100.
Minus 7.10, because it has to be minus, otherwise
Yes,
it
sir.
will draw on above. Okay, so minus 7.1, and then I will click on this point. I will click on this point. Yes.
Yes, sir.
Okay, then go to escape or go to this, and now you can draw your wall. So from this point to this point, from this point to this point, and from this point to this point. So you can draw the wall. So go to draw walls, and under walls also, see that property is there. Then wall property above is none. Then wall height below, this has to be 4. This will be 0. This will be 0. And line drawing type will be a straight line.
Straight line.
And then click from this point to this point. Enter. Click from this point to this point. Enter. And click from this point to this point. And enter. Go to escape or go to this and save this. Yes.
Yes, sir.
Clear?
Clear, sir.
अच्छा लग रहा है?
Yes, sir.
कुछ नया
Yes,
सीखा
sir.
ऐसा लग रहा है आज?
Yes, sir.
Yes, sir.
पहले बोर हो रहे थे ना, क्या वो स्लैब है, वो फुटिंग है और वो कंबाइन फुटिंग है. अब लग रहा है वो सेफ यूज कर रहे. Okay, now here there is no slab, right? And for that, we have to delete this. How we will be deleting it? It's very simple. Go to draw, then go to slab area. You can go to rectangular slab area, and here change this property from that to opening. Okay, I will
Yes,
repeat
sir.
it. I will repeat it. Go to draw rectangular slab areas, and normally the property will be slab by default. You have to highlight it and go to opening. Immediately it will be opening will be unloaded, and property is unloaded. And then either you can drag from this point to this point, or from this point to this point, or from this point to this diagonally. That it is exactly how you were drawing in ETAP. Okay,
Okay, sir.
and escape, and you can see. So this is your slide, right?
Right, sir.
Now what is left? Drawing a beam.
A sand load.
वो लोड वगैरह तो बाद में आएगा रे, पहले ड्रॉ तो कर ले पूरा, right? Okay. Now we are going to draw the beams. Click on it. Go to draw beams. Where is that? Draw beams. Walls, column, beams. Click on draw beams. Whatever shown over here. So we are having only one property, so automatically it's coming as a default. And you will start drawing the beam from this point to this point and to this point. And enter, then close and escape. Just go to this. You can see. So this is how you can create the things. Then you can go to this and you can extrude so that you will find it more easy. अब लग रहा है वो फ्लैट स्लैब
Yes, sir.
Yes, sir.
कमर्शियल में ऐसे ही होता है ना.
Yes, sir.
Yes, sir.
So this is how you can create the structure, and I think because this you need a little bit practice, and right now it is 8:35, but we'll conclude today's session over here. If you have the queries, you can ask me, or we'll conclude the session. See how it has been, and now you can see right now you might feel that it is very easy to draw. If you are having enough practice in ATAB, going for ATAB, then this will be a little bit easy for you. Otherwise, you will whatever we have created. I was explaining a lot of things, but otherwise, entire this process, drawing entire this process is a matter of say 10 to 15 minutes, not more than that.
Sir,
Correct? Yeah. Yeah.
सर वो ड्रॉप पैनल का साइज कैसे फाइंड करेंगे, उसका डेप्थ कैसे
और
निकालेंगे?
नहीं वो तुम्हें देखना पड़ेगा वो फ्लैट स्लैब में. एक्चुअली इट इज समथिंग with respect to the span of the beam plus loading on the slab. With respect to that, see anything more than see most of the time it is more than 6 feet. So 6 by 6 or 1.5 by 1.5, 1.8 by 1.8 is the minimum dimension of the drop panels. And when you will analyze, then if that is not sufficient, then analysis will report you that the area, that area is not enough to resist those shear forces, and then you will have to increase that drop panel this thing. How you can do that? Very simple. You just have to go to define, then go to slab properties, and then go to drop and see that. Okay, not in that. You will have to go to that column. Yeah, go to define and column properties. And in column properties, you have to go to this. And here you have to increase the size. Right?
Right, sir.
Yeah. Let's say that after analysis you found that this 1800 by 1800 size is not sufficient, or the depth is also not sufficient. Then what you will do? You will go for this as let's say 2000, right?
By 2000.
2000, and click OK, and click OK. And you will see that the area has been automatically increased. And if you want to increase the depth of the that, you have to go to the slab properties, and in that drop modify, and instead of that 450 400, you may go for 450, and then change the name so that it will be consistent with your depth.
सर ड्रॉप पैनल का जो डेप्थ रहता है उसमें 400 दिया है, तो उसके अंदर इंक्लूड रहता है डेप्थ ऑफ स्लैब?
Yeah. Yes, slab include रहता है.
ओके सर.
Depth of the drop panel is inclusive of the slab.
अंडरस्टूड सर.
It's not below the slab.
ओके सर.
Yeah. So this is how you can create the structure. Now in day after tomorrow session, or I will say next session, will apply the design strips to this, will apply the loading, and will analyze, and will see the design details. Okay.
Okay, sir.
Yeah. So if you have any queries, you can. But I think today's session you might have found a little bit helpful for you, at least preliminary understanding of how that flat slabs are constructed, or uh, what is the design criteria for flat slab and drop panel.
Yes,
You may
sir.
say that beamless slab. Yes, Samir wanted to say something.
No, sir.
Hello.
I just wanna say that it is very helpful and सर काफी अच्छा लगा आज का एक्स्ट्रा कुछ जानने को मिला सर ये जनरली इंडिया में इतना देखने को नहीं मिलता तो बढ़िया था सर आज का सेशन
नहीं, मुझे थैंक्स मत कहना, सुलेखा मैडम को थैंक्स कहना, क्योंकि उन्होंने मुझे राइट इन द बिगिनिंग किया था, इसीलिए मैंने सोचा कि ये बैच को आई विल ट्राई टू इंट्रोड्यूस एटलीस्ट बेसिक्स अबाउट इट. There are there are a lot of additional things into that, but आपका शुरुआत तो हो जाएगा, राइट?
Yes, sir.
या और आज का सेशन अच्छा था, मतलब पीछे का अच्छा नहीं था.
पीछे का भी सब बढ़िया था सर, आज कुछ नया था तो इसलिए वो चीज थी.
नहीं, एक्चुअली आई ट्राइड, आई वाज वर्किंग ऑन इट, क्योंकि बहुत कॉम्प्लिकेटेड स्ट्रक्चर भी मैं नहीं ले सकता था, otherwise it could have been going tangent to all of you. That's why I said what I can do, so that then I constructed some imaginary structure like this L type and some imaginary dimensions, just to explain how the things are carried in design office. So and this actually this SAFE software is very helpful for creating such type of structures.
इंडिया के
you
अंदर
can-
दिखने को नहीं मिलेगा सर ये.
है actually in Noida as well as in Mumbai, lot of commercial buildings are constructed, and one of my friend is working in that, but he is working in PT area. He says that we are creating 20-story commercial projects, no residential, some 5 to 6 stories as parking, and above the parking there will be entire commercial structures, so up to 20 story.
Okay, sir.
तो ये शुरू हुआ है इंडिया में, शुरू हुआ है, ऐसा नहीं है. You may find this very common in Middle East, and that's why the Sulekha madam asked me, sir हमारे यहाँ तो ये slab beam वाला concept चलता नहीं, और definitely नहीं चलता है. Most of the projects right now which are in progress in Middle East, they are having such type of commercial structures where flat slabs are there, column capitals are there. Sometimes they are having that drop panel less flat slabs, and many times they are having post tension.
सर तो
PD
कॉस्ट
slab.
इफेक्ट भी पड़ता होगा,
Yeah.
कॉस्ट भी इफेक्ट होता होगा सर.
हाँ, तो प्रोजेक्ट कमर्शियल है ना, या वहाँ पे यार
जैसे
एक
वहाँ
बार
जैसे डिफरेंस हो गया सर, यहाँ स्लैब बीम दिया था और इंडिया के अंदर मिडिल ईस्ट कंपनी में ड्रॉप पैनल, दोनों का कॉस्ट डिफरेंस कितना % होता होगा?
maybe 50% higher. See, for this you need a very what I will say skilled laborers, and you need some different type of machinery. There are cables that are used along with reinforcement, because only reinforcement and concrete does not capable to carry the stresses due to that commercial loading on the slabs is coming. So they are using post tension cables. Right now, you might have seen in bridges, in the beams, they are providing cables, and then the cables are stretched after the construction. So that's why it is called a post tension. After concreting, the cables are applied, tension is applied on the cables, and that tension in the cable takes care of all the compressive stresses that are coming on the structure. See, things are very simple. मैं आपको बताता हूँ कि कैसे सिंपल है कि एक एक जनरल अंडरस्टैंडिंग के लिए मैं बताता हूँ कि अगर see what they are doing. See, see, this is your let's say this is your slab. Okay. Now, because of the heavy loading, this slab might sag like this. It is. I'm not saying that it is going to fail, but it is going to create a sag after because of this heavy loading. And you are limited, you are having a limitation with the depth. So later on it will bend like this. So हम लोग क्या करेंगे, उसको पहले से ऐसा बनाएंगे और फिर लोडिंग आने के बाद ये ऐसा बन जाएगा. बराबर है.
Yes, sir.
So these are the simple ways how the people work on complicated things. The same theory is applied over here. Now I will explain you how. See, if this is your beam and this is your support and this is your support. Because of this loading on this beam, your bending moment diagram may be something like this. Right?
Yes,
Yes.
sir.
So I will have a cable. I will have a cable. Let's say this is my total thickness. This is my total thickness of the concrete. And let's say this is my support over here. And this is my support over here. And I know that my bending, here it will be tension. Here it will be tension. And here it will be tension. So I will have a cable, something like this. So this is my cable, and then this cable is clamped over here. It is clamped over here with some clamping arrangement, and then it is stressed with the calculation. There are calculations, but it is stretched, and so that after then it will try to take the entire loading on this cable, and this concrete and reinforcement will be subjected to lesser stresses, and that's why you can get the reduced thickness of the slab and minimum reinforcement. Are you getting it?
Yes, sir.
So these are the basic principles are very simple. They are just applied, and then complex mathematics comes in picture, and that complex mathematics will be taken care by the software. तो फाइनली हमें कुछ करना नहीं है. अगर फंडामेंटल हमारे सही है, you don't have to do much things. यहाँ पे तुम्हें पता चलेगा ना कैसे कैसे बेंडिंग मोमेंट हो रहा है, तो अकॉर्डिंगली आई विल प्रोवाइड द मैकेनिज्म एंड देन आई विल आस्क वन ऑफ द सॉफ्टवेयर्स अवेलेबल इन द मार्केट to give me the detailing. So how much stress that the cable should carry. Then manufacturer will give me the capacity of that cable, and based on that, I will provide number of cables. That's all. समझ में आ रहा है ना? So concept ऐसे ही चलता है, कॉम्प्लिकेशन कुछ भी नहीं है. हाँ, अगर ब्लाइंडली आप कुछ चीजें फॉलो करेंगे तो एवरी टाइम यू विल सी दैट ओके यार ये यहाँ पे तो अलग प्रॉब्लम था, वहां पे अलग है. प्रॉब्लम एक ही है. Find out the tensile forces, find out the compressive forces, let the concrete take the compressive forces and provide enough reinforcement so that reinforcement will take care of tensile stresses. And if you are having more and more reinforcement, which you might find uneconomical, then you will go for some sort of some advanced structures, something like this, or PT slab, etc. यही कंसेप्ट आपको सब जगह अप्लाई होगी, कितना भी कॉम्प्लिकेटेड स्ट्रक्चर क्यों ना हो. इवन इफ इट इज अ स्काई क्रैपर लाइक बुर्ज खलीफा. बुर्ज खलीफा में कुछ ज्यादा नहीं है, बस यू हैव टू फाइंड आउट द बेंडिंग मोमेंट एंड शियर फोर्स एंड टेक केयर ऑफ दैट with the help of your reinforced structure or PT structure or pre-stressed structure, etc. Okay.
Okay, sir.
Yeah. So with this, so we have in this session we have completed how we can create the structure. And next time we'll apply the loading on the structure. We'll apply the strips, that design strips, and we'll analyze the structure. Okay.
Okay, sir.
Okay. With this, I will conclude today's session, and we'll meet day after tomorrow.
Okay, sir.
Thank you.
Good night, sir.
Good night.
Okay, sir.
Good night, sir.
Good night. Good night.
Night, sir.
Good night.